We are going to continue with Chapter 10, and now we're moving on to alkanes. Alkanes are a specific section of organic compounds. They still contain primarily carbon and hydrogen. They could also possibly contain nitrogen, oxygen, sulfur, or the halogens. So those rules still apply. What's setting alkanes apart from one another is the fact that they are primarily single bonds. When you see this just means carbon-carbon single bonds. They're typically used for like propane that we saw earlier, ethane, things that you would want to burn. They're always going to end in ane. So how you can remember that, alkanes are single bonds, and because alkane ends with ane, so is the name of the compound. You're going to name it by the most carbons in a single chain, and we're going to talk about that a little bit later. This is purely a memorization thing. You have to memorize these prefixes. So, for 1, the prefix is meth. For 2, the prefix is eth, and so on and so forth. So if we have 9 carbons in a row, the word's going to begin with non, N-O-N. There are several different structures we're going to use to represent these alkanes. First one we're going to talk about is the condensed structural formula. When we were in the previous section, we talked about the expanded structural formula. For instance, ethane was the one that we had. So this expanded one relates over to the condensed one by saying, okay, so we have 1 carbon here, we have 3 hydrogens bonded to it. So 1 carbon, 3 hydrogens bonded to it. Then we have the next carbon with another 3. Carbon with 3. If this particular one is butane, we have all these hydrogens bonded to it in the expanded formula. Notice how long it takes to write that. That's why we have this condensed formula. Here's the first carbon with 3 hydrogens bonded to it. So there's our first carbon with 3 hydrogens. The next carbon has 2 hydrogens and 2 carbons. So we only talk about the hydrogen. So next carbon, 2 hydrogens. Then the next carbon has 2 more hydrogens. And then the last carbon has 3 hydrogens. And that's how we get from the expanded version to the condensed version. So here's the expanded version. CH3 is what it condenses down to. So in other words, we're taking out all the lines that are depicting the hydrogen bonds. There's also the zigzag pattern structural formulas. This is the most common because it takes the least amount of time to write. Remember before we talked about carbon having a tetrahedral format. It looks kind of like a pyramid. Well, this allows it to depict that. Anytime you see the end or a bend, that's a carbon there. So there's 1, 2, 3, 4 carbons in this line. It automatically assumes that the person looking at it knows that there's hydrogens coming off of it. So there's 3 hydrogens here, 2 hydrogens here. Notice no matter what, it makes 4 bonds. 1, 2, 3, 4. So if I have 1 bond to another carbon, the other 3 are going to be hydrogens. Here I have a carbon, it's bonded to this carbon and this carbon, which means that it needs 2 more bonds, and those are going to be hydrogens. So if we can compare all of them together, here's the ball and stick. This is if you had a model kit and you would do it. Notice that it automatically becomes zigzagged. That's because of that tetrahedral formula. So that's why it's zigzagged down here. So we can take this and make it into the expanded structure. For instance, here's carbon. It has 1, 2, 3 hydrogens coming off of it. 1, 2, 3, and then it's bonded to another carbon. Then it has the next carbon with 2 more hydrogens bonded to it, and the next carbon, so on and so forth. We can take this and go down to the condensed formula by taking out all these lines for the hydrogen. So instead of having carbon with 3 lines of hydrogens, we could just say CH3, carbon with 3 hydrogens. The next one is carbon with 2 hydrogens, CH2. This and this are equal. They're the same thing. And then this reduces down to the structural formula. 1, 2, 3, 4, 5, 6 carbons here. 1, 2, 3, 4, 5, 6 carbons up there. It's the exact same thing. Notice it's zigzagged. So is that. That's because it's trying to depict it as best as it can. It took out all the hydrogens, assuming that the person who's looking at it knows that there's hydrogens there. There are supposed to be lines here, but the computer program did not pick that up when it converted it over to a PowerPoint. But basically what this is saying is that, okay, we have 4 carbons here, we have 4 carbons here as well. So these two things are the same thing. 1, 2, 3, 4 in a line. 1, 2, 3, 4 in a line. Those are all the same thing. Don't get fooled by that. So this is the expanded structure. So what's the molecular structure? So 1, 2, 3, 4, 5. There's 5 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. That would be the molecular formula. Condensed structure, we're going to take this expanded structure and convert it down and take away all those lines for the hydrogen. So this carbon, the first carbon has 3 hydrogens. The next carbon has 2 more hydrogens. The next carbon has 2 more. Next carbon has 2 more. And then the last carbon has 3 hydrogens. And that would be the condensed formula. So if we're looking at this, 1, 2, 3, 4, 5 carbons. 5 carbons, 5 is pent. So that means that formula name is pentane. So if we're looking at this one, it starts with F. F means 2. So that means it's going to be C2H6. So the condensed structure, we have carbon bonded to another carbon. H, 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 H. This is the expanded structure. The condensed structure will be C with 3 hydrogens and another carbon with 3 hydrogens. Part B, hept, is here. There's 7. So there's 7 carbons. So 1, 2, 3, 4, 5, 6, 7. All of them have hydrogens coming off of it. And so from the expanded formula, we can get down to the condensed formula by looking at each of the carbons individually. So here's the first carbon. It has 3 hydrogens coming off of it. Second carbon has 2 more. Third carbon has 2 more. Fourth carbon. 1, 2, 3, 4, 5. 6. We have this last one at the very end actually has 3 hydrogens coming off of it. And there you go. Finally, we're going to talk about cyclohexane, cycloalkanes. means that they're all linked up kind of like a circle. That's what it reminds me of, even though that's not necessarily true. So this carbon here for propane has 3 hydrogens. This carbon has 3 hydrogens. Both of them, so we have a hydrogen, 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 hydrogen if we were to write it out in the expanded formula. Basically what happens is this hydrogen and this hydrogen goes away and they bond to one another instead. So it's still propane because there's still 3 carbons and they're all still 3 single bonds. We're just going to put the word cyclo in the middle. So here's some examples. Cyclopropane, so 1, 2, 3 carbons. Bute means that there's going to be 4 carbons. Cyclo means that they're all bonded together. Pent means that there's 5 carbons. Cyclo means they're all bonded together. And hex is for 6. Cyclo means they're all bonded together. So if we're naming these, 1, 2, 3, 4, 5, 6, 7, 8. 8 is oct, which means this is octane. 1, 2, 3, 4, 5. 5 is pent. So this is pentane. But because it's all in a circle here, is cyclopentane. IUPAC is just the way that they name it. That's the method that they use. And that's the only method that we'll be using. So let's name these. 1, 2, 3, 4. If we look over here, 4 is bute. They're all single bonds, so it becomes butane. 1, 2, 3. 3 is prop. So that becomes propane. But because it's all in a circle, it's cyclo. 1, 2, 3, 4, 5, 6, 7, 8. 8 is oct. That becomes octane. And 1, 2, 3, 4, 5, 6. 6 is hex. So that becomes hexane. They're all in a circle here, all bonded together. So that means it's cyclohexane. And that is the beginning of alkanes.